Hey everyone, this is the other example that I promised. This time I give you the graph and you tell me what the function is. So we're going to create our function. Okay? Notice that I've detailed my y-intercept here so that you know what that y-intercept is. So let's find our zeros. I have a 0 here, I have one here, and another one here. This 0 is at -2, this one is at 1, and this one is at 3. Right away I can write these zeros as a product of binomials. This 0 I can write as x plus 2 times this 0, which I can write as x minus 1, times this 0, which I can write as x minus 3. Next thing I'm going to do is find the multiplicity of the 0. So this 0, since the graph crosses the x-axis at the point, this must be odd multiplicity. Odd multiplicity means exponent 1, 3, 5, 7, any odd number. As an exponent for this term, I'm going to use 1. For x minus 1, the graph touches. It doesn't cross the x-axis. So this point here must be even multiplicity. So that means that this term will have an exponent of 2. For x minus 3, again the graph crosses the x-axis, so this must be odd multiplicity. So I'm going to keep my exponent 1. Remember, this could be 1, 3, 5, 7. Okay, but I choose to keep 1, the simplest term. And once I have this, the other thing I look at is my end behavior. Notice how in this graph, both ends fall. It falls to the left, and this end falls to the right. So I know that this end behavior mimics the end behavior of my quadratic function. But since they both fall, that means there's a negative in front here, right? And also I know that the degree of this polynomial has to be even. So I have 2, 3, 4. That coincides with what I'm looking at here. This coefficient in front, which we call a, since they're falling to the right and to the left, I know that a has to be a negative number. So a is less than 0. But what number is it? The y-intercept is going to help me with that. If I did not give you the y-intercept, let's make believe I did not give you the real y-intercept of this graph, and I would have asked you, look for the y-intercept. This is what you would have done. We would have multiplied 2 times -1 squared times -3. We would have expanded f of x. We would have done this. X plus 2 times x minus 1 times x minus 1 times x minus 3. We would have expanded what we found, and we would have multiplied each one of these numbers together. Okay, so let's do that. 2 times -1, -2. -2 times -1, +2. +2 times -3, that's -6. Plus, don't forget that this in front has a negative, right? Because of the end behavior. This has a negative. I don't know if it's a -1 or whatever number it is, but there's a negative there. So the end result here for now is going to be +6, right? Let's do that again. 2 times -1, -2. -2 times -1 is +2. +2 times -3 is -6, and -6 times this negative gives you 6. So if I were to say that this is the polynomial for this graph, I have not reached at the real polynomial, because when I calculate my y-intercept, I get a 6. And the graph tells me that my y-intercept is at 48. So when this happens, I know that I need to compensate with this coefficient so that when I calculate this again, I do get a 48. So right away, I tell myself, well, if this comes out to 6, what do I need to multiply by to get to 48? And the answer is, well, I would need to multiply by 8. So straight away, I know that I need an 8 as my leading coefficient. So now my polynomial is complete. This would be my polynomial that coincides with this graph. This would be your answer. And you can check again to see if you get your y-intercept correct. You take -8 times 2, -16. -16 times -1, +16. +16 times -1 again is -16. And -16 times -3 is +48. So now I do get the y-intercept that I need to have. Okay, this is one way to figure out what your leading coefficient is. What we did is we took our y-intercept, which was 48. We divided it by our y-intercept that we found before we even knew what the real one was. And that tells you what your leading coefficient needs to be. That's 8. And you already know it has to be negative. I hope you understood this example. I'm going to try and make another one and see if you get more help with it. If you have questions, feel free to comment on the comments down underneath this video. Okay, I'll try to read them and answer your questions. Have fun with this and study, please.